Okay. See, as you know that the name of your book is Calculus,
Yeah.
right?
Yeah.
Calculus is divided into two parts.
Okay.
Differential calculus
Uh,
and integral calculus.
okay.
For both, especially basically for differential calculus, we need to
Uh,
know the concept of limits. Limits is just beginning of calculus. We just study
yes.
in the beginning of calculus. Once limits you understand, then we can do differential calculus, and once differential is done, you can do integral calculus.
Yeah.
Fine. So I'm just going to start with limits concept. See this. I'm not going to give any definition of limits. I'm going to give you the concept. For example, suppose I have like question I have. Yeah. You know what a function is? What is a function? You know, right?
Uh,
Don't worry, I'm not going to ask you the definition of a function. You have an
okay.
idea about functions, right?
Yeah.
See, for example, this is a function.
Uh-huh.
And you know that we have given the two definitions of function. When x is not equal to 0, it is x plus 2. When x is equal to 0, then it is defined as 0. So when x is not equal to 0, it is understood when x is not equal to 0. So there
Mm.
is a possibility that x is greater than 0, or there is a possibility x is less than 0. For both, there is a same definition of function. Yes?
Yes.
And of course, third part is there when x is equal to 0. I want to know limit of this function
Mm.
when this variable x is approaching 0. This is how we write. I'm saying I want to know the limit of the function f of x when x is approaching 0. Now, what is this x approaching 0?
Mm.
Means I'm not asking you value of this function at x equal to 0, which is obviously clear that
Yeah.
when I replace x equal to 0, when I replace x by 0, the
Yeah.
value of this function is 0 only,
Mm.
right? But
Yeah.
what does this mean that x is approaching 0? It means if suppose I go graphically, it means this thing. See, x is here, x is approaching 0, but we can have any real number. X may approach any real number. Now this is 0.
Okay.
X is approaching 0.
Uh,
So we know that x we take along x-axis, and f of x we take along y-axis. X is approaching 0, so we can have any number
uh,
towards left of 0. X is approaching 0. So maybe I can say 0.1,
okay.
maybe not 0.1, I would say minus 0.1, because we are approaching 0 from its left hand side, and its left hand side, of course, there are negative real numbers, right?
Yes.
So when we are approaching means we are going very close to 0 from its left hand side as well as from its right hand side. So it will be minus 0.01. Then I can take the value of the function as 0.001. You can see I'm decreasing the value of variable x, and we are going close to 0 from its left hand side.
Right.
Same way, we are going to find this when x is approaching 0 from its right hand side. From here, from its right hand side, I can take the value of x as 0.1,
Okay.
right?
Yeah.
0.01,
Okay.
0.0001, 0.4 times triple zero is here, huh? 4 times 0.1, and so
Yeah.
on. So we are approaching x. So when someone is asking you, okay, what is the value of this function?
Uh,
When, not value, they'll ask you that what is the limit of this function when x is approaching 0? So you are going to find left hand limit, which is in short form we call LHL. What is this? This is limit of f of x when x is approaching 0 from its left hand side? Negative. 0 raised to the power, this negative sign tells you that we are going close to 0 from its left hand side. Same way, we are going to find right hand limit, which is RHL in short form, and which is denoted by limit f of x is approaching 0 from its right hand side, so that is why it will be a positive.
Okay.
Okay, so whenever we are asking you limit, you are going to find LHL, you are going to find RHL, and of course the value of that function at x equal to 0, which is nothing but this.
Okay.
When all these three are equal, we say that yes, in fact, not all three. I would say when LHL and RHL, these two are equal, I say that limit of this function exists. Now, sometimes, whenever we start this topic, students get confused that why are we studying these limits? I mean, why don't we just find the value of this function at the points which are close to 0, less than 0, and greater than 0? The thing is, we are approaching this function. In this given example, I know that this function is defined at x equal to 0, so there is no issue. But you will get the functions of this form also. You can see that this function is not defined at x equal to 2, because at x equal to 2, this function is not defined. In the denominator, you will get 0, right?
Yes.
Yeah. So what we do is we find left hand limit that we are approaching 2. But I'm not saying that x is 2. I'm
Okay.
saying we are approaching 2 from left hand side. So x has to be lesser than 2 and very close to 2. It
Okay.
can't be, 1. It can't be 0. No, not at all.
Okay.
So same way, we find the limit x approaches 2 from its right hand side.
Okay.
And what is the use of finding these limits? In this example, I explained that, sometimes, function is not defined at the point, but still we find the limit at that point. Like here. Why do we do that? As I said in the beginning, that it is the beginning of calculus, differential calculus. The differential calculus you must have studied in physics and science in your junior grades, how to find velocity over a time period, right? So this is speed also, distance over time,
Yeah.
right? Basically,
Right.
I would say time interval. So in this, with the help of limits, we find instantaneous rate of change, speed, velocity, acceleration, and so on.
Okay.
Okay?
Mm.
Instantaneous rate of change we get to know with the help of this. Like
Okay.
here, what is
Yeah.
this to? This is just a question. But these we are going to study after this. In differential calculus, you are going to study the applications of differential calculus where the concept of limits will be used, and you will learn actually that what is the benefit of studying limits.
Okay.
Is that fine? So
Yeah.
going back to the question, now how do we find LHL and RHL in this particular question? Let me do this. See, now LHL was, I'm rewriting, it was limit of f of x is approaching 0, negative. Now what you have to do for doing